the second video. I'm sure you did if you're listening to this. First thing we're going to do here is we're going to create a line segment RS that is the difference of those lengths. So instead of copying those, I'm going to copy the length of this shorter one. Get that length. And then if I'm going to find the difference, I'm going to need to subtract that amount from the longer one. So I'm subtracting that off. And so now I'm going to rename this instead of A and then a little less than half of the way to B. And I'm going to make this point R. And this distance here that I subtracted off. So my S would be right there. So this length here is RS. And notice that I circle where it is, so I know when I'm correcting your stuff, you're going to say, hey, this is the length, or something like that. So I know that you're going to label stuff. All right. In section 5.1, they discuss the difference between an axiom, theorem, and conjecture. Hopefully we know that an axiom and a theorem are kind of the same things. A lot of people say that an axiom would relate to some theorem, and a conjecture is totally different. Conjecture can be proven wrong. Most of the time we take theorems as being correct all the time. So let's get started on 2.1. What is an angle? I'm pretty sure you all know what an angle looks like and know how to measure them. And an angle is just a measurement between two rays. Measurement between two rays. Could it be the measurement between two segments? Sure. Could it be the measurement between two lines? Can you do it in that way? Sure. It's the intersection. And how do we measure those? Well, we know that in a circle there are 360 degrees, and that's kind of a carryover from the Babylonians. You don't hear a whole lot about Babylonians. They had a base 60 math, which is pretty odd stuff. But the wheel in there. And so if we take 360 degrees, which is carried over, base 60 times 6 makes the whole circle. It's just a measurement, the part of a circle that is in here. And we cut it into 360 degrees, and we just cut it out. If I'm going to do a notation of 60 degrees, I'm going to put a little degree symbol up there to indicate that it's a degrees and not just 60 length or whatever we're talking about. So make sure you put a label on that. That's going to make life easier for you and I. It is not always possible to name an angle with just a vertex, so it is best practice to label angles with 3 points. What we're talking about there on the labeling part of this, oftentimes to name the angle, we would say angle. We put an angle symbol in front of it. A, B, C. The middle letter is always the vertex. And one of the ways to name angles is, the preferred way is the 3 letters. But there's also using just the vertex. And the reason they say that we can't always use that, put this B, A, C back in here. The reason we can't use just angle meets at that vertex. So anytime there's more than one angle that meets at a vertex, you have to, there is no want to or should be or anything, you have to use the three-letter. And so I think it's always just better to get used to using the three-letter name all the time. Using a protractor, so if I use my protractor, no, it's not. Well, let's use this protractor. So if I use my protractor, I can measure my angle so if I measure up here, put this through the 0, move this up to that line, or put that at 0, and move this one down to that line. It looks like I have a 35-degree angle. And notice on my electronic one, it gives me the measurement in here. Okay? So always notice on here, one of the number listing starts at 0 and the other one is at 180. So if my angle would have been drawn like this, I would have used the other side of my compass, the one that starts at 0 on that side. So always make sure you're measuring from the 0 out to. And I explained that down here. Draw an angle that measures 43 degrees. I'm going to start by using my straight edge to put that on there. And then I'm going to get my compass that'll move. And I'm going to put it on the starting point. And then I'm going to make a mark out here at 43. So looks like 1, 2, 3. Looks like right about there. And then I'm going to move my compass out, and I'm going to use my straight edge again to start and then go through my 43-degree angle. You should practice drawing those things a little bit because it does take a little practice. Angle AOB intersects the arc of a circle that is 1/10 of a circle. What is the measure? So we said that a whole circle is 360. If it's 1/10 of the circle, then it has to be a 36-degree angle. How can you draw an angle larger than 180 degrees? Describe it, the process, complete sentences, and then use the process to draw angle X, which is of measure 325 degrees. So, let me take my compass, draw myself a straight edge, and we know that if I go the whole circle, that's 360. 360 minus the 325 gives me 35 degrees. So I'm going to make a mark out here at 35 degrees. Right there. And then I'm going to move my away, and I'm going to finish drawing my angle from the start here through there. And then the last part to indicate, because we know this is a 35 in here, 35 in there, we know that this, make sure you put the arc in there if you're going to go above 180 degrees, we would say that is 325 degrees. So that's how we would go about doing that. Put that cute little guy in right there. Alright, types of angles. We have the acute ones, which are less than 90 degrees. We have the right angles that are equal to 90 degrees. And we have the obtuse angles that are greater to get particular, there's something called a straight angle that is equal to 180 degrees. There you go. And a reflex angle, like we just did, a reflex angle like the 325 on the previous screen. Straight and vertical angles. Remember that a straight line produces a straight line that measures 180 degrees. So if I draw that angle in there, that's 180 degrees because that's a straight line. So line AB and line CD meet at that point E. Woo. Back to that. And we know that the measure, notice the notation here, you guys need to get good at the notation. That's one of the hang-ups that Humpty Hump kids get, is they don't have a whole lot of time on notation stuff, so they goof that up a lot. Measure of angle CEA is 42 degrees. Determine the measure of the other angles. So if we know that a straight angle is 180, we can take 180 minus that 42 and get that this angle over here has to be 138. But then again, this, get rid of that. Angle AEB is also 180 degrees, so 180 minus the 138 also gives me that 42, so that one's 42. And the same logic as that one causes this one to be 138. What that means is, and this is going to be true of all of them, if you have vertical angles, which means anytime two lines cross, these two are vertical angles, those two are vertical angles. Doesn't have to be straight up and down to be vertical angles. As long as they're across from each other when the lines cross. All vertical angles will be equal to each other. All vertical angles will be equal to each other. Supplementary angles. Two angles that add up to 180 degrees. Anytime two lines cross, you're going to get a pair of supplementary angles. Because we know a straight line makes 180. Anytime lines cross, you get two angles that add up to 180. So here are 180, there's supplementary, there's supplementary, there's supplementary, all of them are supplementary. Complementary are angles that add up to 90. So we have a right angle and it gets cut, and those two angles would add up to, let's put some letters in there. Let's call it A, B, C, D. We would say angles CBD, CBD, and angle ABD are complementary. Vertical angles, we talked about that. Any angles that are across from each other will be equal to each other. We'll talk about congruent to each other. If any two angles are congruent, they have the same measure. Congruent means same. Actually, equal means they're the same measure. Congruent means I can take one of those angles and put it on top of the other one, and they would be the same size. Alright, so that's enough for my second video. Log on for your third video.